Good morning, good afternoon, and good night to doctor and everyone. I'm Leader E from SEB2, matrix number J22A0246. We are from Group F. We are going to present our case study. Our topics is failure analysis in material testing. For introduction, failure analysis is crucial for engineers and researchers as it helps identify how material fails, such as through fatigue, corrosion, brittle fracture, or ductile fracture. Understanding these failure modes allow for better design of materials and structures to withstand specific stresses. Additionally, insight of from failure analysis guide modification in design, material selection, and manufacturing processes, thereby preventing future failures. These proactive measures improve safety, enhance product reliability, and extend the service life of component, ultimate, ultimately reducing cost and increasing efficiency.
Thank you, Lee. My name is Fitra and I will share about common failure mode. Failure mode is the process by which a part gives up. There are examples of common failures such as fracture, fatigue, corrosion, wear, and creep. Fracture means the breaking of material into two or more pieces, and there are two different types of fracture, brittle and also ductile. A ductile fracture presents by a significant plastic deformation before ultimate rupture, while brittle fracture is a type of material failure characterized by little to no plastic deformation before rupture. And for example, in real life, for fracture is like cracked screen cell phone still bending before breaking. And we can see the difference from the figure 1 how ductile fracture and brittle fracture looks like. And from the table 1, we can tell that energy absorption for ductile is high than brittle. And for appearance, ductile looks more rough and fibrous, while for brittle, flat, shiny. While for materials, for ductile, usually metal, certain of polymer, and some alloys. However, for brittle, usually materials we use from ceramic, some polymers, and certain of metal at low temperature. Next, we will look up on a fetish failure. Occurs when a component fracture under silica or repeat loading at stress level too low to cause fracture in a single cycle. Fetish have through three stages. First, crack nucleation stage. Second, crack propagation, and last one is solder fracture. For example, in real world, such as airplane wings and coat hangers. And for corrosion failure, is a material failure related to corrosion and it happened due to material selection and environment. Example of corrosion is corroded pipes and rusty bridge. For the next failure is wear failure is a degradation of a material surface brought on by contact with another material. Example of wear is gears, shoes, and car brake. And lastly, creep failure happens when a material slowly deforms and breaks under constant stress, and it usually happens at turbine blade in jet engine and also bridges and building.
Testing technique for fracture. The first we got scanning electron microscopy (SEM). It provides high resolution imaging of fracture surface at microscope level. It using electron to scan the fracture surface, which produces detailed image. It can detect fine features such as river patterns in brittle fractures, deeper patterns in ductile fractures, and striation in fatigue fractures. The second technique is X-ray diffraction (XRD). It used to analyze the crystalline structure of material. X-rays are directed at the material and the diffraction pattern is analyzed. It can identify phase changes, residual stresses, and crystallographic texture. which can contribute to fracture. For the third is hardness testing, used to measure the material's resistance to deformations. It using techniques like Vickers, Britnell, or Rockwell hardness test. Variations in hardness can indicate changes in material properties due to hard treatment or work hardening, which can influence fracture behavior. The last technique is non-destructive testing, NDT, used to detect surface and subsurface defects without damaging the materials. Techniques like ultrasonic testing, radiography, magnetic practical testing, and dye penetrant testing. It can detect cracks, voids, and inclusions that can
Root
act
cause
as
investigation,
stress
visual inspection,
concentrator and
examine the
initial
physical
fracturers.
condition of the valued board and the surrounding area. Look for
Hi,
sign and
hello and
word, deformation,
Assalamualaikum.
corrosion,
My
or
name is
any
Nurwani
other
Sabrina
visible
binti Muhammad
damage.
Hasni and
Material
my ID
analysis
number is
check check the
J22A0237.
material
I'm
properties
gonna
of the
cover
board
for
to
this
ensure they
part,
meet
which is case
the
study.
required specification.
Firstly,
This meet
we should
involves
observe the
chemical
problem. For this
composition
part,
and
I
analysis
choose
and
camera
mechanical
digital
testing,
troubleshoot
like
since it has
hardness and tensile
similarity
strength.
with
Failure
OM
mode
microscope.
identification. Determine how
For
the
observe
board
the problem, we
failed.
must firstly figure
Common
out the
failure mode
problem based from
include
daily
cracking,
situation.
fracture, corrosion, and rot.
I
Load
chose this
analysis.
because it
Invalid
have the
the
same
load acting
situation
on the
with
board
OM.
during
For
operation.
example,
This include
digital
board,
camera troubleshoot
board
might
static and
produce
dynamic
blurry or
load.
distorted image,
Environment factor.
and
Consider
you might
the
notice some issue,
operational
which is
environment such
it have
as
problem with
temperature,
focus or
humidity,
lighting.
and exposure
And
to corrosive
for OM
substance.
analysis, it have
Installation
poor
and
focus,
maintenance record.
uneven
Review and
illumination, or
installation
image distortion.
process to setting and maintenance
Secondly,
record to
regular check.
identify and
Does and does
procedural issue.
affect the lighting of
Simulation and
camera as
testing.
well as OM.
Perform simulation
It
and
better
physical
to
tests
clean
to
it so the
re-
lenses might
replicate
clear
and
from the
failure
dust and dirt.
condition and
We should check the
validate
appropriate lenses
hypotenuse.
for our specimen if it necessary. And next, detail inspection. Check for physical damage, camera, crack in lens or body, and proper battery. OM it might have scratch on lens, misalignment of optical, and lighting source. Next is testing and isolation. Test result with some different condition or sample with OM to finalize the problem. For example, by using different lens, eyepiece, or light source. And 5. Solution implementation. After we identify the problem, it's best to replace the faulty parts or component with a new one because um, for OM analysis, it better to do like that since we might have a new result or we might have find a new solution for this problem. And 6. Verification. We take new photos to ensure the camera is now produce clear and focused image. As well as OM, we use a new sample to ensure the
Conclusion,
microscope is now
including
producing
to the failure
clear
study
and
of the base
accurate
plate
image.
board in the
That's
radial
all for me.
fogging
Thank
machine.
you.
For installation, technique, environment corrosion, and unsuitable board design were the main reason for failure. Strength concentration, the fatty crack isolates from the board improper size to support the dynamic load. The board were further witnessed by severe compromise during installation due to improper tool setting production insufficient clamping force. It is advised to strengthen corrosion resistant, ensure proper installation technique, conduct routine maintenance check, and improve board design for better load management in order to provide future value. By talking this step, the radial fogging machine, dependability and safety will be considerable considerable increase.
Hi and Assalamualaikum. My name is Nurwani Sabrina binti Muhammad Asfi. My metric number is J22A0337. I'm gonna talk about preventive measure. For proper material selection, material chosen has high strength and toughness. For example, aluminum alloys and titanium alloys. Um, we choose these two materials since it could withstand fracture and they are best for apply in aerospace and construction industry. Secondly is design modification. For design modification, implement damage tolerant materials so we could prevent catastrophic failure. By assuring the load distribution properly, the material should be designed with proper load distribution and avoid sharp corners or notches. Thirdly is process improvement. By optimizing the process of material inspection, which could reduce the possibility of material failure by trying to improve manufacturing efficiency, reduce defect, and enhance quality control. And lastly, quality control. For quality control, material testing in manufacturing material is crucial since the material have to perform various tests to evaluate their properties, which is tensile strength, impact resistance, and fatigue. That's all for me. Thank you.
Thank you, Wani. I will continue on collaboration with industry. So, what benefits we can get from sharing knowledge? We can bring new expertise and idea at the same time, closing the gap between theory and practice. When we working together, we enable to the researchers to comprehend the real world difficulty associated with the material for application. Then, accesses real world data enables us to more quickly and can access a big data, and it also become more easier to spot emerging failure trends, to identify material weakness or new failure mode is that may not have in the lab. Lastly, learning from practical experience. Case study and lesson allow them to understand the root cause of failure, not just considering about material properties but also the factor like design, manufacturing, and maintenance practice. Industry can provide insight into the feasibility and cost effectiveness of potential solution, and the result can help the researchers.